When evaluating a system of linear equations in two variables graphically, there are three different cases for solutions that we should keep in mind. The first case is where the graphs intersect at a particular point. So say we have our axes, where this is x and this is y. Then, for example, one of our lines could be going this way, and the other line could be going this way. And clearly the point of intersection is the point where the two lines meet, which is that green point right there. In which case, the solution of this particular system and systems like these is the ordered pair x comma y, whose coordinates are the point of intersection. So the solution here would be this particular green point x comma y. And these, for this case, the system of equations is called independent. So whenever you have the lines meeting at a certain point, intersecting at a certain point, it's called an independent system of equations. Now case 2 is where the lines are parallel and they never intersect. So for example, let's draw a better y-axis right there. So that's a little better. So we got the x and we got the y. And so in the case where they're parallel, we got one line going like this, and we got another line, a certain distance away from it, but they're parallel, as in they're not skewed and they never intersect. So since there's no point of intersection, then there's no point that they have in common, and thus there is no solution to the system. And now systems like these, in which they have parallel lines for the graphs, are called inconsistent, an inconsistent system of equations. Right, inconsistent. Okay, and that was case 2. Now, case 3, the final case, is that the graphs coincide. That means that they're actually the same line. So, for example, let's draw our axes again. We have our first line, which will go like this, for example, and then the graph of the second line is going to be right above it. So, in this case, the graphs are the exact same point, so they intersect everywhere. Since they're both the same graph, they intersect at all the points in the line, and thus we say that there are an infinite number of solutions to the system, i.e., all the solutions on this line. And in this case, the system of equations is referred to as dependent. Perfect-ish. Okay, so those are the three cases for solutions when evaluating a system of linear equations graphically.